now let's talk about finding the zeros in this polynomial. We're going to use the calculator to do this too. And I look at my TI, and it appears that I have 3 zeros. It appears that I have one right there. It appears that I have one right there. And it appears that I have one right there. It's a polynomial of degree 5, which means that I couldn't have any more than 5 zeros. And just as a hint, you're going to reduce that by 2. So I can have 5, 3, or 1 real zero. There's clearly some imaginary zeros, and imaginary zeros always come in conjugates. So that eliminates 2 of them right there. So having 3 zeros makes a lot of sense to me. And I'm just going to calculate one of them here so you can kind of get the sense of how to do it, but it's the same process as with the local minimum and the local maximum. We have to be clear we define the interval. So let's find the first one on the left. I go second calc. I want to find a 0. I'm not looking for an intersection. Intersection is an intersection of 2 curves or 2 lines. The 0 is where the function has the value of y equals 0. So it is an intersection with the x-axis. It is a 0 of y. So I want to find a 0, 2. And I'm going to have my left, well, that left bound is way over to the right. So I'm going to kind of move it over to the left. I'll do it by my punching the cursor. A little bit more. So that's a good left bound. I've kind of gone off the charts a little bit. I can bring it back there so where I can see it. That's a good left bound. And for my right bound, well, I can see that 1 would be the right bound. A negative 1 would be a right bound for a 0. So I'll just type in -1. And I've defined my interval, and I can see that somewhere in there I suspect there's a 0. It looks like it's touching the x-axis. I'm not going to make a guess. And sure enough, I have 1 0 right here that is at the point -2, 0. Well, we may as well just finish this off. I'll go second calc, 0. I need a left bound. As long as I'm over to the right of the other 0, I'm okay. There's a left bound. And I can see my other 0 is way over here. It looks like it's at the origin. So I'll go my right bound of, let's just say, 0.2. So I'm getting to the right side of the origin. I'm going to push enter, enter. And sure enough, I have another 0 right there at 0, 0. And what's my final 0 going to be? Second calc, 2. I'm looking for zeros. Let's move it over a little bit. That's my left bound. I'm on a right bound. I can move it over like this, so I could have put in the number 2 or 3 or any number I wanted to. That was greater than where I think it intercepts. Again, you can see my little my interval marks are over here and over here. So I'm covering the interval that I want to cover. I press enter. Well, it looks like it's calculating for a long time. Yes, it was. So that looks at x equals 1. So this is the point right there, 1, 0. And that's how I calculate my zeros. Just remember that when I ask for a 0, I want to know the value of x where it makes y equal to 0. That is also my x-intercept. So what if I want to know my y-intercept? I want to know what my y-intercept is. Well, I happen to know on this one already that it's 0, 0 because my y-intercept, it's crossing the x-axis and the y-axis. But the thing you got to remember about the y-intercept is that on any function, there is always only going to be one y-intercept. If I had a y-intercept, 2 y-intercepts, then I no longer have a function, because I would have two values of y for the one value of x, and we can't have that. So there's always going to be one y-intercept, and that y-intercept is going to be where x is equal to 0. So it's a little bit easier to find a y-intercept with a polynomial. I just substitute 0 there, 0 there, 0 there, and 0 there, all for x. Oh, here too. And I can see that my y is going to be equal to 0.